In this video, we're going to begin by reviewing some of the fields within cognitive neuroscience that examine this neural basis of cognition. There are a number of ways that you can test the brain regions involved in a cognitive process. One really common method is neuropsychological testing. This compares the effect of injuries to different brain regions on particular psychological tasks. So this has been done for quite a long time. It's a real staple of cognitive neuroscience, and it has evolved to look at more finely nuanced brain regions to include additional experimental paradigms and additional questionnaires. One really popular method right now is the brain connectome. This is basically a mapping of functional connections in the living brain. So there's two primary neuroimaging tools that are used for mapping the human brain's connectivity. This is diffusion tensor imaging and functional connectivity magnetic resonance imaging. DTI measures actual neuroanatomical pathways. This can be done quickly on many living brains, and measurements can be made simultaneously in the entire brain. So DTI is structural in its method, so it looks at the white matter pathways. So while it uses an MRI scanner, just as the functional connectivity MRI does, it uses a different type of sequence and a different type of measurement. And what it focuses on is water molecules in the brain and how water molecules, the directionality of these water molecules changes as a function of the directionality of the white matter fiber track. So they can use DTI to track and identify the various white matter fiber pathways. It's highly useful also for assessing white matter track pathways that may be damaged from traumatic brain injury. fcMRI measures the functional correlations between brain regions. So this identifies consistent patterns of connectivity or nerve tracks in the brain. And it uses temporal or time-based correlations between neurophysiological activity in different regions to infer functional connectivity. So to give you an idea of how this would work, we know, for example, that increased activity in the prefrontal cortex is associated with decreased activity in the more limbic regions of the brain, such as the amygdala. And so you can test this specifically. You can use fcMRI to assess if increases in the prefrontal cortex, if the increase predicts a specific decrease in the amygdala, for example. If the amount of increase that an individual exhibits in their prefrontal cortex predicts a corresponding decrease in their amygdala that would occur right afterwards, so this increase and followed by a decrease, then that would be a strong functional correlation between those two brain regions. Another very hot field right now is social neuroscience. This is an interdisciplinary field that seeks to understand how the brain mediates social interactions. Much of social neuroscience is based on theory of mind, and this is the attribution of mental states to others. This builds on the mirror neuron theories that we talked about in the last video. And what is particularly important about theory of mind in the context of social neuroscience is that we infer the minds of others by observing their behaviors and listening to their words. So feelings and beliefs of others may be similar or different from our own. So if we look at other people and we see that they have a particular expression on their face, or if they're engaging in a particular type of action, then our mirror neurons would fire and they would see, okay, this facial expression, what would my own mental state be if I were exhibiting that facial expression? That's some of the basics of theory of mind. So not lots of social neuroscience focuses on the role of empathy and other sorts of differences in behavior that predict how good we are at assessing other people's mind states, how the mind states of others and the mind states of ourselves do or do not align with the behavior that we exhibit, and what are some of the factors that predict how people cooperate, how people trust each other, larger behaviors and theories that are dependent upon understanding the mental states of others. Another important aspect of behavior is self-regulation. We control our emotions and impulses as a mean for achieving long-term goals. And in addition to theory of mind, the prefrontal cortex regions are very critical in self-regulation. And here's an example in the following video.
Who, as a result of diseases, have damage in certain sectors of the brain. It's a little hard to picture it, but you can think of them especially in the front part of the brain. And when there is damage in those areas, what happens is that patients become unable to read certain social clues out in society. So they will have difficulty picking up the significance of a facial expression, or the significance of, for instance, a shrugging of the shoulders. And likewise, those patients will also not be able to perform in relation to what is expected in terms of the social contract.
You see those okay, Joe?
Meet Joe. Until a stroke in 1989, he was a high-energy, creative outdoorsman with a cheerful, fun-loving personality. Now, according to his wife, Dee, he's always in neutral.
A windmill?
This experiment gets to the heart of Joe's problem.
A woman and a little boy.
The electrodes are recording his skin conductance response, a measure of his emotional state.
Picture of a skinny man. How's skinny? Awful skinny. Somebody ice skating. There's a man burning himself.
Typically, people generate a strong skin conductance response to the disturbing pictures, but not to the routine, bland ones. And yet, no matter what the picture, Holocaust victim or smiling child, Joe's response is flat, outside and in. Intellectually, he understands what he's seeing, but emotionally, he doesn't connect. Like Phineas Gage, Joe has lost key components of his social brain. The evolved mechanisms that, behind the scenes, smoothly process and integrate reason and emotion have been damaged.
The goal of the game is to guess at which decks you can make the most money off of.
To test his ideas about the social brain, Damasio uses experiments designed with his colleague Antoine Béchara. They're called the gambling experiments.
In front of you there are 4 decks of cards.
You're hooked up to a polygraph machine and told to keep turning over cards from any of the 4 decks.
I'll give you some money each time you select a card.
With every card, you win play money. 2 of the decks pay $100, but they have an unexpected sting in the tail. You might have to pay the experimenter, sometimes as much as $1,250.
So you owe me $200.
With the other 2 decks, you win only $50, but the possible penalty is much smaller, less than $100 on average. The goal of the game is to make as much money as you can, so it has some of the same elements as the game of life. Uncertainty, some risk, punishment and reward, and a blend of reasoning and intuitions.
You win $50, but you lose $50, so it's even.
Initially, I did what most people do, favor the 2 high-paying decks. That is, until the experimenter started demanding big penalties.
So you owe me $50.
Having learned my lesson, I eventually curbed my gambling impulses and shuffled over to the safety of the other 2 low-payment, low-punishment decks.
You win $100.
Typically, over 100 plays, a normal subject will retreat to the safer decks about 70% of the time. Damasio's frontal lobe patients do the exact opposite. By halfway through the game, they're often bankrupt, which has happened to some of them in real life following their brain damage. Now, how can their judgment, their prediction of future consequences, be so disastrous? Damasio believes there may be a tantalizing clue in the polygraph responses. As the game went on, my graph showed a new trace that wasn't there at the beginning. I had the usual response after each penalty or reward, but I also began to develop a response just before picking a card from the risky decks. And that response increased as the game continued.
You win $50, but you lose $25.
In other words, according to Damasio, my brain was gradually learning to anticipate the penalty and sending an alarm signal, a gut feeling, if you like, that could be picked up by the polygraph.
The phrase gut feeling is actually a very good one. It just shows that people have been very wise for millennia in spotting the fact that some of their choices are very closely connected to emotions, and they're very closely following on emotions. In other words, the gut feeling is a marker for something that ultimately may be good or bad.
Now here's the key finding. None of Damasio's patients showed this anticipatory response. The neural networks that allow gut feelings about good or bad outcomes to guide rational decision-making are damaged. There's a break in the complex feedback loop of circuits that underpin reason and emotion. And so there's no way to make appropriate social judgments, and no way for the system to be calibrated or tuned by experience.
So that video is a really nice example of the role of the prefrontal cortex regions in self-regulation. The relationship between self-regulation and behavior with respect to the frontal lobes is also demonstrated in children who are poor at self-regulation because they actually have not yet developed their prefrontal cortex. So the prefrontal cortex is the last region to develop, and so as the slow development of the prefrontal cortex occurs throughout childhood, that corresponds to increases in self-regulation from no self-regulation to late adolescence, where you have a higher self-regulation, but your prefrontal cortex doesn't actually mature until your mid-20s. So it's not after until 25, 26 that your frontal cortex will be fully developed to allow full self-regulation. It's also important to understand that our self and our social interactions link together as a single mental action. So when we engage in behaviors that are reflective of ourself. The things that happen to us reflect of ourself. So we assign a great deal of meaning to our reactions, and how we evaluate stimuli and how we react really do reflect who we are. So are you a reactive person? Are you a happy person? Are you a sad person? Aspects or traits that are part of our personality, these have foundations in the way we react and interact with our world. This is also evidenced by the fact that when we express attitudes or ideas about human groups, this reveals activation in the prefrontal, anterior cingulate, and lateral parietal regions. These are all regions that are involved in self-regulation. Another field that's really hot right now is neuroeconomics. This is an interdisciplinary field that seeks to understand how the brain makes decisions. Neuroeconomics combines ideas from economics, psychology, and neuroscience in an attempt to explain decision-making processes by studying patterns of brain activity as people make decisions. So in the past, you have, in trying to figure out how people make decisions, then researchers would basically just look at the types of decisions people made, or have them try to think and about what motivated their decisions, and then state some of that information to the experimenters. Well, when you engage in that type of perspective reflection, then that significantly changes your thought processes around your decisions. And so how we tend to think back how we made a decision is not necessarily reflective of how we actually made the decision. by using neuroimaging, then we can get a window of some of the processes that might be involved in making decisions. And then you can test if greater activity or less activity in one region that is corresponded with a particular type of process, such as risk evaluation, for example, then you can see how that process might motivate decisions. Another field that is expanding that is based off of neuroeconomics is consumer neuroscience, and this is where you look similarly at the brain's reaction to stimuli, to products that are presented, to see if it will predict preferences that people have, purchase decisions that they'll make, and with a particular goal of the consumer aspect of, all right, what are people doing with their money, so to speak. So lots of times companies are particularly interested in these studies because then companies can conduct research to see, okay, well, what do people prefer about particular products? What are the ways that people are reacting to specific products or to specific situations that are influencing their purchasing and consumer behavior? When we make decisions, we have a reflective system that is deliberate, slow, rule-driven, and emotionally neutral, and this is in the ventromedial prefrontal cortex. And we also have a reflexive system, and this is fast, automatic, emotionally biased, and this is in the lateral prefrontal, medial temporal, and posterior parietal cortex. So think of the reflective and reflexive systems as being of contrasting sort of hedonic, what you want in the moment, versus your long-term goals and what might be better in the long run. So you've just gotten an extra bonus, or what do you do with your tax rebate? Do you go with the hedonic, reflexive, fast, emotionally biased decision to purchase something that you want or indulge, or do you go with the deliberate, slow, sort of goal-oriented, reflective system that would suggest saving the money, investing it, or doing something strategic?